We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello and welcome to the lecture on telephone networks on the subject of telecommunication switching system and networks from Electronics and Communication Engineering Department of Gandhinagar Institute of Technology. Today we will be covering these few points that you see over here: network planning, routing planning, numbering plan and signaling techniques. Network planning is the planning of telecommunication systems comprising of a network of switching centers including various plans. From initiating the network to extension of the network based on the increased load, network planning plays quite a vital role. Few of the definitions or a few of the services that are provided are switching, routing, flow control, security, signaling, traffic management and accountability, along with administration and internetworking. This diagram will give you quite a bit of an idea what network planning completely ensues. At the service level, what we will be seeing are the basic services, value added services or the toll free services that we as an end user are able to access. At the network level, what is expected and what is being given is the routing of calls between various cell centers, various telephone operators itself, traffic management, load management, fault diagnosis, maintenance and security also. At the accounting level, you need to be able to take charge of the billing, or how much is each client or a customer going to be charged for it, and how much inventory do you have and how much inventory do you would be needing more, so that all consists under the inventory control. At the management level, what we're seeing is marketing of your network so that you can get more customers into it, so that you can increase your revenue, network planning and extension, so reaching more areas which you had not reached priorly or previously, new network equipment and installation, and policy decisions. Let's take a look at those definitions in bit detail now. Switching, the process of interconnecting incoming calls or data to the appropriate outgoing channel or destination is referred as switching. Routing, the ability of the network to select a path to connect calling and called subscriber for telephone conversations or providing path for data transfer between source and destination is referred as routing. Flow control, it is the ability of the network to reject traffic. Managing the rate at which traffic enters the network is referred to as flow control. A network without effective flow control becomes very inefficient. Security. There are 2 ways of providing security of the network. First, to increase the security of operation in presence of faults. To provide adequate security, the complete network may be duplicated or even triplicated in some cases. Second, preventing unauthorized access to the network and the data it carries. This may be achieved by passwords, data encryption, and providing limiting factors in accessing the network. Signaling. A signaling system link the variety of the switching systems, transmission systems, and subscriber equipments in a telecommunication network to enable the whole network to function as a whole. Traffic management. The ability of the network to keep track of traffic levels is referred to as a traffic management. It is quite useful in both short-term and long-term basis. Accountability. This includes billing, charging, accounting, and inventory control. This is the ability of the network to track the users of the network and to charge revenue from them as and when needed. Administration. It is related to the ability of the network to identify the load of a network and providing corresponding upgradation of parts, extension of network facilities, etc. Internetworking. It is the ability of the network to perform the functions needed to communicate with and across other networks. This includes providing routes for traffic crossing through, into and out of the network, and allocating resources such as buffers and link capacity to traffic originating from other networks. This we have already seen in quite detail over here. routing plans, or also known as routing plans. Routing plans refers to the procedures that determine which path in a network are assigned to which particular connections. The switching centers may use fixed routes to each destination, or even adaptive routing can be used. Adaptive routing can be employed in which each exchange may use different routes for the same destination depending upon traffic conditions. For effective routing of a call, some form of interconnection of switching exchanges is quite necessary. So few routing topologies that we are going to see over here. First is mesh connected networks. As you can clearly see from the diagram, you have 5 different nodes present over here, and each node is connected to another node via one single dedicated line. Right, so even if the route between A and B breaks down or has some issues or has some latency introduced in it, the traffic between A and C is not affected because A and C are directly connected via a whole different another path. It's a one-to-one communication from each node to each and every other node existing in the system. This topology offers the highest reliability and security at the cost of increased infrastructure. Star topology. This is a quite preferred topology because this connects everything to a central hub or a node. As you can see over here, you have got 5 nodes present over here, and each of them is connected to one central node. This is called a star network or a star topology, right? You cannot just have like this one node in the center. You can have multiple nodes connecting to a central node, and each of these central node connecting in further down the line to another central node, and so on. The TE represented over here is the tandem exchange, the exchange through which each of the exchange communicate with each other. Numbering plans. So numbering plan is used to identify the subscribers connected in a telecommunication network. The main objective of numbering plan by any nation is to standardize the number length wherever practical according to the CCITT recommendations. National Telephone Services. An international public telecommunication number is also referred as an NSN. NSN consists of the country code, national destination, and subscriber number. Basically, this system gives you an idea, or this system gives you rules and regulations on how any specific country can go about giving phone numbers to its various subscribers. International network. An international network an international public telecommunication number for international networks consists of 3-digit country code, a network identification code, and a subscriber number. The country code is always in the 8xx range. The identification code is 1 to 4 digits. International numbering plan. So we'll be talking a little bit in detail about this, but one of the most important ones that we need to be talking about is the national numbering plan, and specifically how it relates to the India. So national numbering plan in India itself. As you can see, the NSN, the national significant number, right, consists of a few different parts of it. The first part is called the area or the trunk code, then is called your exchange code, and third is your line number. Imagine your landline number. If you have to dial your landline number from out of state, from out of Gujarat, how would you go about it? First, and specifically even if out of India, first you'll be dialing +91, that is your country code. Then you'll be dialing your area or the trunk code that you have, that is if you're in Ahmedabad, so it's 079. Then it's your exchange code, so usually the digits are the 26 or 27 or something like that, and then you have the rest digits are your line numbers. Those are your specific identifiers, right? So numbering plan. DOT, Department of Telecommunication of India, has released its national numbering plan in April 2003. Right? It was last reviewed during 1993 and it has then been released. Numbering scheme. There are 10 levels of numbering scheme starting from 0 to 9. In each level there are many sub-levels as classification of services. Level 1 are special services used for emergency services, supplementary services, inquiry, and operator assisted services. So these would be kind of the numbers which you have in 3 to n digits. That is like if you want to call police, you have 100. If you want to call ambulance, you have either 108 service available, or if you have in these special government helplines that you have are 4 digits or 3 digits. So yeah, these are covered under level 1. Level 2 to number 6 are PSTN subscriber numbers. This format contains a telephone exchange code and subscriber number. The important ones that are the level 9 services, are the ones that we used right now. The range of numbers in this level 9 except 90, 95 and 96 are reserved for cellular mobile services. Yes, the numbers that we are starting to use. Since this hasn't been revised completely yet, and you also are using various geo numbers which start with 7s or 8s and nowadays even 6. So, right, so all those things, cellular mobile services fall under level 9 services of India's national numbering plan. Signaling techniques. So here we'll be talking about various techniques through which these systems communicate through each other. So yeah, we talked about network. So network, you have planned the network and routes. So you're giving the routes to go from one exchange to another exchange, or from tower to another tower through these numbers. But how do you actually transmit? What format does it go through? So that is where the signaling techniques come into picture. A signaling system links the variety of switching systems, transmission systems, and subscriber equipments in a telecommunication network to enable the network to function as a whole. The signaling are classified according to the internal signaling of an exchange, signaling between exchanges, and signaling between an exchange and a subscriber. Traditional signaling schemes use the same channel to carry voice and data, and control signals to carry out the path set up for speech or data transfer. This signal refers to as signaling in-channel signaling or per trunk signaling, that is also known as PTS. But the alternative is common channel signaling, CCS. This is the one which is nowadays more commonly used and widely used. CCS uses a separate common channel for passing control signals. It couples the signals for a large number of calls together and sends them on a separate signaling channel. Here you can see in-channel signaling is then divided into further part loop disconnect, DC signaling, or AC signals of multi-frequency. Voice frequency is then in-band or out-band, and it's pulse-coded modulation then. In-channel signaling. Automatic propagation of signaling information enables the simultaneous process and release of associated facilities. In common channel signaling, information must be relayed from one node to the next node in store and forward fashion. Integrity of speech and signalings are maintained as they are on the same path. Special equipment should be provided for integrity as they are traveling on separate paths. Separate paths also means over here literally physically separate wires. Separate signaling equipment is required for each trunk and hence is expensive. Only one set of signaling equipment is required for a whole group of trunk circuits, and therefore CCS is economical. Transfer of information such as address digits is from common control network originating office, that is voice channel, receiving office, common control network. Transferring of information is directly between control elements, that is processors of various systems. Trunks are held up during signaling. Trunks are not required at all for signaling. Thank you.